let's look at 42. So in 42, we have here the whole area, 180 square inches. Bottom and sides. Okay, so there is also a printed area. So this is the printed area. And they say that only the top has 2 inches. So here, this is 2 inches, 1 inch, 1 inch, 1 inch. What dimensions will give the largest printed area? So we want to maximize printed area. So like always, we have to find the printed area, a function, and then maximize it. Okay? So we are given the entire area. So I'm going to have to use some names. I'm going to say this is X, label those, and this is Y. So obviously 180 must equal 180 equal to? Excellent. We have that. But now I'm interested in the printed area. So the area, I'm going to write P, so we know what it is. The printed area. Can anyone tell us the printed area? Step by step. So what is the width and what is the height?
1 inch.
So the printed, the X, so this is X minus 2 inches. Is that clear? X minus 2 inches?
Yeah.
Good. And what about this?
Y minus 1.
So Y minus 1?
3 inches?
Yes, and 2. So Y minus 3. Good, awesome. So I'm going to distribute here, xy minus 3x minus 2y plus 6. Let's stop for a moment and see, is this okay for everyone? Oh, sorry. Okay, so x minus 2 inches is this, and y minus 1 inch and minus 2 inches is this. So this is x minus 2, and this is y minus 3. That's why the printed area, which is a rectangle, is width times length. Is this okay, everyone?
Yes.
So then xy and minus 3x and minus 2y and plus 6. But this is basically 180. So I'm going to replace it eventually, but I have to get rid of one of these two. It doesn't matter which one. I have this relationship. I have to solve this one for whatever you want, so I can replace it in here. You can solve it for y, and then what will you say if we solve that for y, that equation for y? Yes, 180 over x. Good. I'm going to put it here. 186 minus 3x minus 360 over x. Negative 2 times this, negative 360 over x. So now I can say this is indeed a function of x. I shouldn't put it there because over there it's not. Over here it is. So don't write it like that. Good. So we have the function. So the most difficult situation was averted. So I have the function. That's really all I needed. That was the most difficult part, to find the function. I'm asked to find the maximum of this function, which is the area of the printed section of the poster. So then, what do I do? As you see, they're all the same. They all have the same steps.
Find the derivative.
Very good. A prime of x. This is nothing. This is -3. Can anyone give us the derivative of this? -360 over x. I'm always hoping that my students will remember this because this is super important. How much is 1 over x prime?
It's 180
Over 2.
over x.
-1 over
Over
x squared. Yep. So this will be plus 360 over x squared. So the -360 stays in front of this. But when you differentiate 1 over x, you get -1 over x squared. So the negative with the negative will go away. So all you have is 360 over x squared. It's very important to remember this formula. We need it in chapter 5 a lot. And moving forward to Calc 2. So then, the least common denominator is
X squared.
very good. So then I have -3x squared plus 360. Perfect. Okay, I found the derivative. Now what? What is the next step after I find the derivative?
Critical numbers.
Yes, so critical numbers, they could come from two sources, from f prime of x being undefined when x equals 0, but who cares? How can it be 0? We are talking about this. How can it be 0? So nothing from undefined. So from a prime of x 0, which portion here has to be 0?
Numerator.
Yes. So I have -3x squared plus 360 equals 0. I'll divide both sides by -3. So x squared minus 120. And I will, one option will be this and take the square root. And then I get x equals plus or minus. So this is 40 times 3. I'm sorry, 4. So it's 12. No, I need a 4, right? 4 times 30, right? So 2 the square root of 30. And the measurement unit was inches. And you can say, no, only x equals 2 the square root of 30 inches. We cannot have negative. But I have no idea what this gives. Who knows? I don't know. So I have x, I have a prime of x, I have a of x, I have whatever that is, 0 and infinity. Of course, 0 is not possible, infinity is not possible. So this is 0. I go back to the derivative. Nobody should spend time on the denominator, it's always positive. Can you please plug in 0 and tell me the sign?
Negative.
Yes. When we plug in 0, positive, right?
Yeah, positive.
Good.
Yeah.
That's okay. So when we plug in 1,000, this will be much bigger than this.
Negative.
Good. So now I know for sure that this number gives the maximum printed area. What is the maximum printed area? We'll find it in a moment. It's not sufficient. We only have x, which is to the square root of 30 inches. We have to go back and find y. So I know how much this should be, and I know how much this should be for this to be maximum area. So I have to find y. 180 divided by x. So y equals 180 divided by 2 to the square root of 30. I will simplify, that's 90. And I'll simplify by, and I will rationalize. So y equals 90 over the square root of 30, and we multiply by the square root of 30 and divide by the square root of 30. So we have 90 the square root of 30 divided by 30, 3. So then y equals 3 the square root of 30 inches. And now I also want to find the maximum area. So where is my function? Here's my function. Plug it in, and I will replace x by 2 to the square root of 30. So in y equals, I would put this function in, and it was 186 minus 3x and minus 360 divided by x, and all I want to plug in is 2 to the square root of 30. Okay, so it's 120.27. Can anyone give us the measurement unit for this maximum printed area? This one.
Inches
Squared.
Squared.
Yes, awesome. Inches squared. Yes, indeed, inches squared. This is the end of the material for test 3. So let's think for a moment what we want to do. Do we want to continue with another problem? We still have time. Or you want to just give you a list of what to expect on the test? Or we want to work on another problem? Or both?
the list of the test.
Okay, so let's look at the list. It's a very short list, basically. So for test 3, number 1, a graph. Number 2, Rawls theorem. Number 3, mean value theorem. Number 4, Newton's method. Number 5, optimization. And the last one, number 6, it's L'Hopital's rule. Of course, the 0 over 0, infinity over infinity, because these are the only ones that work with L'Hopital's rule, but also the other ones, like infinity minus infinity, that have to be changed into this, or just a simple other method, not L'Hopital's rule. Then we had 0 times infinity, which is just a simple algebraic manipulation, and those 3 powers, 1 to infinity, 0 to 0, infinity to 0, which, as you know, are more cumbersome. That's it. So a problem from each, and here maybe 2 or 3 limits. Literally not more than 6 or 7 problems. This is a short test. I love short tests.
The test is next Monday, right?
We set it up for Wednesday the 16th. So what I recommend, let me change my camera here. So what I recommend is on either Wednesday or Monday, I let you decide, we will review. I'm looking at the calendar. I have a calendar here on the wall. So either the 9th or the 14th, we will review for this test. I have to start chapter 5. You can say, oh, you only have 6 sections left on the entire course. Yes, but it's a lot. It's a lot to absorb, a lot to think about.